Welcome to Precalculus Algebra, and here we're going to study the transformations of functions. And this is part one, and in this section, or in this video rather, we're going to just be learning about the transformations, and in the next video we're going to be actually graphing functions with multiple transformations or combined transformations. So in this video what we're going to do is use a program, a free graphing program called Desmos. So you can just type in Desmos, do a search on it, and you'll find a free graphing calculator. It's super easy to use and really helpful. So we're going to study transformations. I'm going to go ahead and graph functions over here using Desmos, and then we're going to generalize the transformation over here, and we're going to list all of our transformations. And we're going to have 10 of them in total. So let's start off. Let's start off with a function y equals x squared. So Desmos, we just type that right in, and we get a nice parabola y equals x squared. Now what would happen if we take this function x squared and we simply add 2 to it? Let's check it out. So y equals x squared plus 2. And what we can see is that the graph has been transformed, right? We have a new graph now, and it's basically the old graph x squared but shifted up 2 units. And that's because we added 2. And if we would have added 3, it would have shifted up vertically 3 units and so on. So let's write that down generally here. That if you start with the function f of x and you create a new function y equals f of x plus 2, okay, the effect is that you have a vertical shift up 2, okay? And you know, so it could be plus 7, plus 1/2, and so on. Now, you can also vertically shift a graph down, right? So instead of adding 2, let's go ahead and see what happens when you subtract 3, let's say. So let's go back over to Desmos and say, okay, instead of adding 2, let's see what happens when we subtract 3. Okay, and like we see that we have a new graph here. It's basically x squared but shifted down 3 units. And so we can write over here that if you have y equals f of x, let's say take away 2, it could be take away 3, take away 5, you know, subtract any number you want, subtract any positive number you want, and the effect is that you have a vertical shift. In this case, it's going to be down 2, as written here, okay? All right, so now we have vertical shifts. Do we have horizontal shifts? And the answer is yes. And let's see how those would work. So once again, we're starting with x squared. And if you type in y equals, now if you replace x with x minus 2, right? So I basically have y equals x squared, but instead of x, I replaced x with x minus 2. The effect is that the graph has been shifted 2 units to the right horizontally. And so that would be called the horizontal shift. And so what you do is you write, if you have the function y equals f of, now x has been completely replaced with x minus 2, and we write that like this. The effect of that is a horizontal shift, and it's going to be 2 units to the right. So it's to the right 2. And do you think we can shift to the left? Sure. Instead of adding 2, what would happen if we change this to x? We replaced x with x plus 2. And we see that the new graph has been shifted 2 units to the left, right? So the new graph is in green. Oh, by the way, the graphs are color-coded, right? So the green graph, this green symbol tells you that it's the green graph, and red for red. And we can see that the green graph has been it's basically a shift of x squared, or it's a graph of x squared, but shifted 2 units to the left. Generally, if you replace x with x plus 2, that's the effect. So if y is equal to f of x plus 2, if that's the new function you have, then your graph is a horizontal shift, right? A horizontal shift of what? Of f. F has been horizontally shifted to the left 2 units. Okay, so we're going to actually now, so like I was saying, there are 10 transformations. It's easy to easier to write these next two transformations if we use a different function. So instead of x squared for these next two transformations, I'm going to use the function the square root of x. So we just type in the square root of x, and we get a graph like so. It's basically half a parabola on its side. Now what would happen if you simply multiplied this function by -1? That is, if you get this function, y equals negative of the square root of x. Oh, and what happened? Well, this graph in orange, is a reflection of the original graph across the x-axis. And generally that's true. If you have y equals the negative of some function you originally had, then your new graph is a reflection of f, right? It's a reflection of your original function across the x-axis. So if you simply multiply your old function by -1, that's what's going to happen. And then, so we have a reflection across the x-axis. Is there also a reflection across the y-axis? And the answer is yeah. And what would that look like? Well, all you do is you replace x with -x. So if we look at the graph of y equals the square root of -x, okay, so what did I do? I just replaced x with -x, and we see the effect. The new graph is a reflection of the original across the y-axis. So let's write that down. If your graph is, if your equation is y equals f of -x, what's the graph of that going to be? Well, it's going to be a reflection of your original graph, one reflection of f across the y-axis. Okay, and then we have four more transformations. And to illustrate these transformations, I'm going to introduce yet another function. Now this is a function that you have probably never seen before, but you will see it in trigonometry. It's called the sine function. And all you do to graph it in Desmos is just type in sin with x. And the point of that function is, all it does is it generates this wave. And it's going to be illustrative to show you the next four transformations by referencing this graph. So what we're first going to do is I'm simply going to take this function and I'm going to multiply it by 2. So I'm going to show you what it looks like when you have y equals 2 times sine x. Let's get rid of that gap right there. Whoops. Okay, so 2 times sine x. And what happened? Well, you can clearly see that if the red graph was made of wire, we've clearly stretched it vertically. So we stretched it up and we stretched it down. It's like somebody pulled up and down on that original function. And that's exactly what we say. We say that we had a vertical stretch. So when you have y equals 2 times f of x, what you have is a vertical stretch. And now you can see why it was easier to use the wave to illustrate this. Now a vertical stretch, it's a stretch if you have a number in front greater than 1. So what's important here is that the 2 is greater than 1. If you change it to like 1/2, for example, what would happen? So if we had a 1/2 out there, well, instead of a vertical stretch, what happened? Well, it's like you've taken the wire and you've compressed it, right? It's like a vertical compression. So we call that a vertical shrink. So if you have y equals 1/2 times f of x, then the graph gets shrunken vertically. It's a vertical shrink. Okay, and the reason is because the number out in front that you're multiplying the function by, in this case the 1/2, is less than 1. Okay, now I wrote it for 1/2, but this could be any number less than 1. It could be 1/3, 1/7, and this could be any number greater than 1, 2, 3, 5, whatever. In fact, all of these can be different numbers except for here, the -1, the negative here, and the negative there. Those are actually -1. All the others I used 2 just as an example for clarity. Okay, and then we can also introduce two more transformations. And what happens if you, instead of this function, what happens if you replace x with like 2x, for example? So let's say you had y equals sine of 2x. Well, we have two graphs here, and let's go back to the original. So there's the original graph, and notice that you go up and down, and you complete that up-down wave in a little more than 6 units, right? And let's look at the next one, the transformation. And what happens by the time you get to 6 units? Well, you've gone up, down, you've done it twice. So it's like somebody took the original graph, this graph, imagine it was a piece of wire, like a spring, and we compressed it. And so that's why we say that this graph is a horizontal, it's a horizontal shrink or horizontal compression, right? So when you replace x with 2x, you get a horizontal, you shrink the graph horizontally. Let's write that down. Y equals f of 2x, that's a horizontal shrink. And what matters here, just like in the previous case, is that what matters is that the 2 is greater than 1. So anytime, if you had f of 3x, f of 5x, or whatever, you're going to be shrinking by whatever factor is there. So I shrunk by a factor of 2. It's like somebody compressed by a factor of 2. And then what happens if this isn't a 2? What happens if it's a number less than 1, like 1/2? Whoops, that's not what we want. So let's get rid of the x. So sine of, or try that again. Let's use parentheses. Okay, so now I've replaced x with 1/2 x, right? I simply, everywhere I saw an x, I replaced it with 1/2 x. What's the effect? Well, the effect is that you've basically, if this was the original function, you basically have stretched it. You've pulled on the left and you've pulled on the right as if it was a piece of wire, and you got this stretched out horizontally. Okay, so let's write that down. If you have y equals f of 1/2 x, the effect is that you have a horizontal stretch. Okay, and what's important is that the 1/2 here, that is whatever you're multiplying x by, what's important is that it's less than 1. Is that you can stretch functions, you can shrink them, and you can do all these other transformations just by doing what I did here for these functions, or what I did over here, what I showed you graphically. But these are the general transformations that we're going to use graphing going forward. So these are our 10 transformations, and in the next video we're going to go ahead and actually graph functions by referencing combinations of these transformations. So I recommend that you go ahead and look up Desmos and play with it, and go ahead and see if you can replicate these transformations knowing functions that you have seen before, like x squared. See if you can replicate all these transformations. It's great practice. Okay, until next time.